Now let's go over question number 163, missing ranges. The question says you are given a inclusive range, lower and upper. So we have our range of numbers and a sorted unique integer array of numbers. So our array is going to be consistent of numbers. They're going to be unique and sorted, where all elements are in the inclusive range. A number x is considered missing if x is in the range, lower and upper, and x is not in nums. So for example, what this is saying is, let's say we have our array. So this is our array of sorted unique integers, and we're going to have two numbers, our lower and upper bound. So let's say that our lower is 1 and upper is 10. Now our array is going to look something like 2, 3, 5, 8, and 10. Now our missing numbers are going to be any number between 1 and 10 that's not in our array. So that's going to be 1, 4, 6, 7, and 9. So these are the missing numbers. Return the smallest sorted list of ranges that cover every missing number exactly. That is, no element of nums is in any of the ranges, and each missing number is in one of the ranges. Each range, A, B, in the list should be output as, so these two rules, A with the arrow B, if A does not equal B, A if A is equal to B. Okay, so I think this will be better illustrated when we look at our example. And let's look at our example 1. And I actually want to kind of edit our example so that it covers all the edge cases. So I'm going to change my lower to -2. So our input array is going to look the same. 0, 1, 3, 50, 75. Our lower is going to be -2 and upper is going to be same, 99. So our range of number ranges from -2 to 99, and given our array we have to look for number or range of numbers that's missing, right? So we start at -2 and we look for missing numbers. So that's -2, -1, and we have 0, and then after it's 2, 4, then it's all the way to 49, then it's 51 through 74, and then it's 76 through 99. Now remember, we have two rules for our range of numbers, right? If we are missing a range of numbers, something like consecutive numbers, so that's -2 and 1, we will write this as -2 with an arrow with a -1, and this 2 will just be kept as 2, because if we were to have 3, we would do 2 arrow 3, but we just have single number 2 here, so we leave it at that. And then it's going to be 4 through 49. We're handling this over here. And then next it will be 51 through 74. And then finally, our last one is going to be 76 with an arrow till 99. So we're missing -2 to 1. That's a range. We're missing 2. That's a single number. So that's not going to be a range. So that's not going to have this arrow sign. Next one is 4 to 49. So that's going to have an arrow. 51 to 74, same thing. And lastly, 76 through 99 is going to be the same thing. Now, there are 4 cases that you have to handle. First one is going to be, well, you have to handle these single numbers. And second one is going to be this range of numbers. And third one is going to be, well, what if we're missing numbers over here? So something between our lower bound and our first number. And lastly, this is a third one, and fourth one is going to be the same. What if we're missing range of numbers towards the end? So between the last number and the upper bound. So think about those 4 cases and try to implement your solution, and come back to the video when you need help. If you guys find this helpful, make sure you guys like and subscribe. Thanks. Now let's try to implement our first solution, and our first solution is going to have a time and space complexity of O of n. Now what we're going to do is we're going to iterate through our given array, so that's input array, and we're going to check 2 adjacent numbers. So 0 and 1, and 1 and 3, 3 and 50, 50 and 75. And if the difference between these two numbers is, if it's not equal to 1, that means that there is a range of numbers that we have to put in into our result. So for example, we're looking at 0 and 1. What's the difference between 0 and 1? Well, it's equal to 1, right? So if the difference is 1, that means that these two numbers are consecutive numbers. So nothing goes between 0 and 1. And it's not like we are counting for decimals. We only count for integers. So it's 0 and 1. So that means that there is nothing to add between these two numbers. So first thing, I want to create a variable named output. So let output is equal to an empty array. And next, let's just return that over here. All right, that looks good. And now we want to be able to iterate through our array. So let's do, starting at index I, we want to iterate nums.length, and we increment by 1 each time. Now I want to create two variables, and that's going to be lower bound and upper bound. So lower bound is going to equal to nums at index I, and on that number we're going to add 1, and I'll explain why later. This one is obviously going to be upper bound, and that's going to be nums at index I plus 1, and for this one we subtract 1. Well, what are our lower bound and upper bound variables? Well, remember that we want to look at two adjacent numbers in our array. For the first iteration, our current number is going to be 0 and our next number is going to be 1. So we're comparing again these two numbers. Well, if it is the case that the difference is equal to 1, we don't really have to do anything, right? So we go on to the next one. Now we check. Well, our two numbers are now 1 and 3. Well, is the difference not equal to 1? Well, that means that we have to add a number for our output array. And we know that it's going to be 2. But let's say that we added that number to our output. And let's go on to the next loop. And that's going to be 3 and 50. Now, we know that our bounded numbers that we have to add is going to be 4 through 49. So this is exactly doing just that. Well, our range of numbers that we have to add to our output is going to be nums at index I plus 1, which is 3 plus 1, and our upper bound is going to be 50 minus 1, which is 49. So this variable is just doing that. Now we need our checks. So if it is a case that our number at index I plus 1 minus nums at index I, if this does not equal to 1, you have to do some kind of operations, and I forgot my s over here. So remember that if the difference is equal to 1, we don't do anything because they are consecutive numbers. If it's not, we have to do some kind of operation. Now let's take care of a few things first. I want to create two functions that's going to just give me an output. So first one is going to be add num, and remember that if we are adding single number, we have to convert that into a string. So this function is going to take a parameter number and just return it as a string. So that's the string n. And our second number is going to be called, let's actually have it here. Let's do add range. Add range is going to take two numbers, which is going to be the lower bound and the upper bound. And for this one, we're going to return, we pass in our lower, and we need our arrow, and we pass in our upper. Okay, so that looks good. So we have our functions. Now we need to handle our two cases. Well, we know that if lower bound and upper bound is equal to each other, we have a single number that we have to add. So it's not one of those with an arrow. And this is our case for this one. So we know that just one number comes between 1 and 3, and that number is 2, right? So our lower bound is going to be 1 plus 1, which is going to be 2, and our upper bound is going to be 3 minus 1, which is also going to be 2. So if the lower and upper bound is equal to each other, we know that we have to add in that single number. So let's handle that over here. So if lower bound and upper bound is equal to each other, we want to add to our output. So output dot push, and remember that we have to add num, but we have to convert it into a string. So let's just use that function. Let's just pass in our lower bound, and we are actually done with this one. So let's try running it and see what we get. And I actually made a spelling mistake. This should be output, and you can see that we have our 2 over here. So that's looking good. Now we need to be able to handle our range of numbers. So something like 4 to 49. And that's the other case, right? So that's going to be else. We do the same thing, output.push. But this time we want to use our add range function. So we do add range and we pass in our two numbers, and that's going to be lower bound and upper bound. And you can see that we have our temporary result. But as you can see, this is actually not a full solution because, well, first of all, we are definitely not handling our upper bound and lower bound correctly. Well, what if we had a case where our lower bound was -10, and that means that we need a range of number -10 to -1, and obviously we don't handle that over here. And it's the same for our upper bound. Well, we have numbers after this 75, which is 76 through 99. How are we going to handle that? And right now it's just adding 76 arrow, not a number, and we definitely don't want that, right? So what we can do is, first of all, we can actually change our nums array. So even before we start our loop, we are actually going to change our array. So our array is going to look something like nums, and we are actually going to pass in our lower bound and upper bound into this nums array. So let's create an array and let's pass in our lower, the rest of the numbers from our nums array. So we use the spread operator and we pass in our upper number. So if you were to do that, you can see that we have a somewhat okay solution, but obviously it's not perfect. First of all, we actually don't need this last one, and this last one is in there because we are actually looping one extra time. So let's loop one less time, and we can see that that's gone. So that's looking good. So we have our 2, 4 to 49, 51 to 74, and 76 through 98. Well, our upper bound is 99, right? Not 98. And why is this happening? Well, the reason is because, remember, we subtracted 1 here and actually added 1 to our lower bound. So that means that we have to actually do the opposite here. So what we do is we subtract 1 for our lower and we add 1 for our upper. As you can see, we have our final correct result. Now let's check the other cases. Now, if you were to look at our other cases, you can see that everything is actually looking good. So actually this is it for our solution. Let's go over our code one more time. Well, I have my two functions that just literally just changes a single number to a string, and this one just returns an array or range specified by the problem. So lower with an arrow to upper, and that represents range of numbers. And here we are actually overriding our original numbers array by adding lower -1, the rest of the numbers in our array, and upper +1. And remember that we are subtracting 1 here and adding 1 here because when we are calculating our lower and upper bound, we did the opposite. We added 1 to our lower and subtracted 1 to our upper bound. Now we iterate starting from the beginning of the array, and we check or look at two adjacent numbers in our nums array, and we check, well, if the difference is not equal to 1, that means that it's not a consecutive number. So we have to add either a single number or a range of number. If it's a single number, that means that our lower bound is going to be equal to our upper bound. So if that's the case, we add in a stringed version of that number. Otherwise, we add the range of numbers, which is going to be given by lower and our upper bound. And finally, we just return our result, and that's it for this solution. Just one thing, you actually don't need to create these two functions. I just did that because I thought it looks a little neater, but you can just incorporate it here. That's totally up to you. If you guys find this helpful, make sure you guys like and subscribe. Thanks.